this is your daily dose of math here, and today's video we're going over AMC 10, year 2001, problem 15. The problem reads, a street has parallel curbs 40 feet apart. A crosswalk bounded by two parallel stripes crosses the street at an angle. The length of the curb between the stripes is 15 feet, and each stripe is 50 feet long. Find the distance in feet between the stripes. Someone should pause the video and try to prompt yourself before we go over the solution. You've done it? That's great. Now we'll go over the solution. So as you see here, this is a simple geometry problem of the MC10 series, and this is problem 15. So it is the middle bound of the test. It is not that easy and is not that hard. So as you see here, we have the figure, and the figure is drawn for you by me, but on the actual test, the figure will not be there. But this is to help you solve the problem and give you an easier time. So I want you to start by listing the description of the figure. So it says a street has parallel curbs 40 feet apart. These are the top. So whenever you see parallel, it's usually talking about parallelogram. So the top of the parallelogram is the curbs, the parallel curbs, curbs, and this also goes for the bottom. So they're both parallel curbs, and it says that the parallel curves are 40 feet apart. So in this parallelogram, we can draw an altitude, and since they're 40 feet apart, we just write it as 40. And before we go further, we see that feet does not change within the problem. So the unit does not change within the problem. So we can just write 40 because we automatically know that is feet. So 40. So we finished the first sentence. The next sentence says, a crosswalk bounded by two parallel stripes crosses the street at an angle. And these are the stripes because they cross the street at an angle. So, stripes. And it says, the length of the curb between the stripes is 15 feet, and each stripe is 50 foot long. So 50 foot long for each stripe, and the length of the curb between the stripes, which is 15. So these are the two stripes, and these are the two stripes, and the length between the curve is 15 feet long, and it also says that each stripe is 50 feet long. So we have it here. We're just gonna erase this. So we have that, and so we have everything labeled. And remember that this figure is not drawn to scale, and usually in the AMC 10 problems, the figures are also not drawn to scale. So it's a good way not to rely on the problem itself and on the figure itself by measuring the distances. So what it also says what is the problem asking for. So it says find the distance in feet between the stripes. So we know that the total area of the parallelogram is 15 times 40 because the altitude is 40. So the simple formula for solving the area of a parallelogram is base times height. And in this case, the base is 15, and the height or altitude is 40. The height and altitude are basically the same thing. So 15 times 40, which is equal to 600. So that's the total area of the parallelogram. Parallelogram. Sorry if I misspelled that. So we have 600 is the area of the parallelogram. And it also says find the distance in feet between the stripes. So between the stripes, it's asking basically for the altitude. And since the other base is 50, that means the altitude of the triangle is what we're looking for. And that's extremely easy. So the other base is 50, and if the other base is 50, we just have to divide it by the total area. So just area divided by base is equal to altitude, or what we're trying to find. It's basically flipped of altitude times base is equal to area. Area divided by base is equal to altitude. So area is 600. The second base is 50, and the altitude that we're trying to find would be 12. So the answer is C. If there's any problems or concepts you want me to go over, please leave them in the comments down below. And thank you for the recent support. And if you like this video, please like and subscribe. Otherwise, thank you for watching this video. Your daily dose of math. We'll see you in the next one.